So in this example, we're asked to find a power series for a function g of x centered at 0 by differentiating or integrating the power series for f. So you're going to be working on f to get g. And hopefully you notice that g of x is a multiple of the second derivative, right? Because you have a power of 1 here and a power of 3 here. So let's start by taking the first derivative of f, which is simply over here, right? It's negative 1 minus x to the negative raised to the negative 2 times the derivative of the stuff is negative. So that's the first derivative. Taking the second derivative, you end up with 2. And I'm going to write it as 2 over 1 minus x cubed, which gives us almost, right, g of x, except g of x is, right, so 2 times g of x is equal to the second derivative of f. Using that relationship, g of x is equal to 1/2 the second derivative divided by 2. So we can go right to the power series representation. Grab my back. Since we know it's a geometric, I'm going to just manipulate the indices in this example. So we have, if f is equal to the sum of the xk's, the derivative, first derivative, so f prime of x is simply equal to k x to the k minus 1. The second derivative of x, manipulating the indices, is k times k minus 1, x to the k minus 2. So let's look at the relationship here that we have. That's f prime, so we have to divide that by 2. So let's do that, and we get g of x is equal to 1/2 sum of k times k minus 1, x k to the minus 2, which is equal to 1/2. And again, I drop my indices when I work with it at times. I'm going to distribute in. Actually, I'm going to not. I'm going to, this is k equals 0 to infinity. I'm going to get rid of, so we can talk about the interval of convergence. I'm going to work on getting this power to be k so that I can rely on the geometric for its interval of convergence. So let's rewrite this. Oh, I'm sorry. This is k equals 2 because it's a second derivative. So you always start the index, right, one more than the derivative. So one more than, you have to add 1 for each derivative. So in other words, the series here starts at 0. For the first derivative, it has to start at 1, and for the second derivative, it starts at 2. So this is 2 to infinity. So I can drop this back down, which is what I'm interested in doing, to k equals 0. I'm going to subtract 2 from the index, which means I need to add 2 everywhere else. Okay, so I'm going to add 2 here, add 2 here, add 2 here, and I get k plus 1 times k plus 2 x to the k. So now I have a power series for g of x. And the convergence interval I is going to be the absolute value of x less than 1.